Hi everyone, welcome back to ChemHelp ASAP. Today we're going to be talking about acid-base indicators. These are the compounds that turn all sorts of pretty colors when we do acid-base titrations. Let's get started. An acid-base indicator is any substance that has a distinct color change in a specific pH range. So to be an indicator, you must have both of those qualities. You have to have a definite color change, and that color change must happen in a very specific pH range. Now, most acid-base indicators are actually weak acids themselves. And what happens is they will show one color when they're protonated and another when they're deprotonated. If we symbolize our indicator by the letters IN, you will have a protonated form, HIN, and a deprotonated form, which is just IN. Again, these two must have different colors. So for example, a very common indicator is phenolphthalein. It is colorless in its protonated form, which is HIN, but it's pink in its deprotonated form, IN. So on my chart to the right, you can see phenolphthalein is down here, and you can see its color change and in the specified pH range. And this just highlights that some indicators will change from one color to another, but this one goes from colorless to a color. Either way is fine as long as it changes and as long as it's in a specific pH range. Now, the nice thing about indicators, because they're changing colors, the human eye only needs about 1/10 of the initial form to be converted before we will see that color change. This is why when you're doing a titration and you're adding phenolphthalein, you need to only add like a drop or two of phenolphthalein for that color change to become apparent. We just need a tiny amount. All right, so how do we choose the indicator we want for our titration? So the first thing you need to know is you need to know your pH at your equivalence point. Then you want to choose your indicator that changes color at about plus or minus 1 pH unit. So for example, let's say we have a strong acid and we titrate it with a strong base. That is going to have an equivalence point with a pH of 7. So looking at my range of indicators to the right, I want an indicator that's going to change colors at about around 7. So bromethymol blue is going to be a good indicator for that. You can see it's changing right about 7. It's going from yellow through a little bit of green to blue. Now, what if I had a weak acid titrated with a strong base? That is going to have an equivalence point above 7. Now, it does depend on your weak acid how much above 7 that is, but we know it's going to be basic. So I want an indicator that is going to change color after I've passed a pH of 7. So for that case, I might choose phenolphthalein, which is going to change a little bit after 8, but before 9. Then if I had a weak base titrated with a strong acid, that was going to have equivalence point that's going to be below 7. So again, looking at my chart, I might choose a methyl red indicator because again, that's going to change colors below a pH of 7. Now you can get more specific with these when you know what you're actually titrating because of course you need to calculate what your pH is at the equivalence point. When titrating and using an indicator, it is really important that you differentiate between equivalence point and end point. So your equivalence point is going to occur when your moles of acid equal your moles of base. This is stoichiometry. Your end point is going to occur when your indicator changes colors. It is important that you choose your indicator appropriately so that for whatever calculation you're doing, you can assume that the end point and the equivalence point are so close together that it does not introduce error into your calculation. I hope you found this video helpful, and thanks so much for watching.